Why model? I'm sure everybody has heard about the term model, and you have your own definition in your head about what is a model. But before we reach to that, I would like you to think about some of these questions here. You don't have to give an answer, just think by yourself for a few seconds. The first one is, in order to mitigate mortality from seasonal influenza, should we vaccinate children because children are most likely to get infected? Or should we prioritize and give the vaccine to the elderly because the elderly are most likely to die from the infection? Who do you think should be the priority for vaccination for seasonal influenza? Just think in your head for a few seconds. The next question, should we close schools in case of influenza pandemic, or should we implement border controls in the airports or any other entry ports? What is the best to do? And in each of the options, when should we start? Do we have an idea? Just think about it. Next, why can we eradicate smallpox, but we are not able to control obesity? How much more do we need to do in order to eradicate polio? So as you can see, those are very complex questions, very difficult to answer intuitively. Like, we don't really know on which grounds to base our opinion sometimes in order to answer those kind of questions. Or we don't have empirical evidence to support our statement, maybe. And let's first see the definition of mathematical modeler, and then we will come back to that later. A model is just a simplified representation of a complex phenomenon. So we try to make something that is complex, we try to illustrate that in a very simple way. So it's in a very organized way. So this is a model. We have many kinds of models. Animal models. I don't know if some of you have done some lab experimentations with mice and trying to test the effect of drugs, for example, or to block some genes and to see what will happen to the mouse. So we also have mechanical models. But today, we mostly talking about mathematical models. What is a mathematical model? It's a representation of a system or process in a mathematical figure or form in which we use equations to make some simulation of the behavior of the system or the process under study. This is a definition by last. It's it's still very complicated to understand at this level what is really a mathematical modeling. When you will get it when we come to some examples. And in the mathematical modeling, we use population parameters and in forms of symbols, and there is a relationship between different components in the system in using algebraic formulas of mathematics. Why we use models? Because remember, I asked you many questions here about what should we do to eradicate polio. Why are we not able to stop obesity, but we can eradicate smallpox? So all those questions, we can make some sort of simulations using mathematical models to try to see what may happen if I do this intervention, what may happen, what kind of effects can I have. So with the mathematical model, we can get an insight or an understanding on what's the mechanism that influence the disease spread or the disease control within a population. We can also estimate some epidemiological parameters. It's helped us to predict some future trends. A very simple not simple, but I would say some very common mathematical model that you are very used to is the weather forecast. Some people are used to check the weather forecast every morning to see how the temperature is going to be like. Is it going to rain? And what is the chance of the rain? Is it gonna be cloudy? So we always check the weather forecast in the morning to have an idea about the temperature of the day. So they do modeling, they do mathematical modeling, and they make prediction about the future trends. So in the same way, we can do with infectious diseases, and we can simulate interventions to see if I use the intervention A, what kind of results can I have? And if I use intervention B, what results can I have? And we can compare different interventions. For example, if I close schools, in case of pandemic influenza, what would be the effect? And if I close the airports, and what would be the results? We can compare interventions of different interventions using mathematical models. They are not perfect, but they give us an idea about what's the best scenario or what's the worst scenario to take. So this is a very, very important element, predicting the future trends, checking scenarios, and evaluating different interventions. So we're going to go very slowly, step by step, into different building blocks of mathematical modeling. There are steps to come up with a model. As in any research activity, we start with a question, a research question. What are you looking for? What is your research question? This is really important because you need to have a very clear research question. What is your population? What kind of intervention do you want to implement? What effects are you looking for? So you always start with a research question. And just the same, every kind of research, you go to the literature review. You want to know what is known about this problem, what is written about it, what are the missing information, for example, what are the gaps. So you do a very detailed literature review about your research question. The next step, you have there what we call modeling design. It's a sort of study design for mathematical modeling. And then you start setting up the model, like putting everything together. Model quantification, we're gonna see it later. And model validation, You want to make sure that your model really works, and if it's really a good one. If you develop a new model for weather forecast, you want to compare it with other weather forecast companies and see if it's working well. So these comparisons with other models or other already working operational models is what we call model validation here. Once the model is validated, then you can start using your model to answer your research questions or to make some prediction. But if it's not validated, you can go back again. So it's a tremendous efforts. You can go back again. You can go back to each of the steps and see what was wrong until you come up with a model that is well validated and that can be used to estimate or to make prediction.